So progress with the build so far is that I've connected up the video output header here with the relevant ground, red, green, blue, and sync signals. The sync signal goes to the TV out. I've connected up these variable resistors here. Now, the original design or the intention for this was that the variable resistors would allow me to tweak the output levels of the separate RGB components from the output of the resistor ladders. However, currently I don't think I need to do that because with zero resistance on the variable resistor, then I was targeting the SCART or VGA output levels anyway, so I'm going to trust that I don't need that. So I've just added these little jumper wires here just to connect the output straight through with no resistance. Well, okay, apart from the resistance due to dodgy wire connections, but I'm going to ignore that for now. On this side of the board, I've set up a debug memory pattern input generator. So it uses it uses only one because I only connected one, although there's two others. There's a 161, which is just a simple counter. This is a 1 megahertz clock. The 4-bit output goes into the lower 4 bits of the memory address here. I've set up a memory address which is going to be 9C something something. So these 4 bits are being set by the counter. These next 4 bits, the upper nibble, is going to float high. Now, I've only driven the lines low that I want to drive low. So this is 0, 0, and then the next 2 bits are set, which is 8 and 4. So 8 and 4 is C. And then it's high, low, low, high, or 1, 0, 0, 1. So that's 8 plus 1, which is 9. So that sets up 9C on the memory for the 16-bit memory. Now, because the expansion bus here is not headed up, everything on there floats high. So effectively, that's enabling writes to every single bank of potential expansion RAM, all at the same time. However, there's only one bank of expansion RAM on this layer of the board that I'm really interested in, which is going to these 3 2114s here, the nice fast 2114s, which are fantastic little memory chips. And the original board uses 2114s as well. So I'm actually only interested in the memory address which is asserted by logic level 1 on the first bit of the extended memory bus here. So because it's all floating high, this one floats high too, and that means that writes will go to the extended memory bus bit 0, so 1, plus 9C plus F, and then whatever these lower 4 bits are going to be from the timer. So what this means is that it will be continuously writing to 9CF and then 0 to F, so 9CF0 to 9CFF, and it will be continuously accessing those memory addresses if the memory enable write signal here is driven low or high. So when I'm driving it low, that means it's going to be writing information into these memory chips, and all of the rest of the memory address circuitry. Because this is floating high, it means that all of the memory address circuitry is going to be in contention with wanting to read pixels. So that means we should see a contention pattern on the screen, as the contention with the palette memory is happening during visible screen refresh. So if I go up here and I switch it on, there we go. We should see, in theory, a nice jaggy pattern, which we're not getting. Why are we not getting the jaggedy pattern? And that's probably because I don't know. But we are getting a nice stable output, which is really, oh, that's because I'm tying it low. Let's tie it high. Let's switch it off again to clear the memory, and then switch it on again, because I think I've just written the same color value to all of the memory. There we go. So now we're getting some jaggedy patterns, which is what I would be expecting. Yeah. So I think when I switched it on with the memory being driven low, I think it was always writing to that memory. But at the moment, the extended memory bus is basically saying I want to have contention with the RAM. So the address for the RAM is coming from the memory address rather than the address for the actual pixel that it wants to look up. So what I can do now is that if I take this wire here and I force bit 0 of the extended memory bus to be low, it will turn off the contention for that memory, and then we get a nice consistent purple screen, which is great because that means that the pixel color is being read from the RAM now rather than from the address, which is being primed by the external memory bus. So this means that this particular pixel in this particular address has a kind of like a light purple color, which is quite pretty. If I let it float high again, then it goes back into contention. I'm just wondering if I should really get some proper header pins installed on this so it won't pop out. However, let's see if I can force it to kind of like stay there. Yes, kind of. Oh, no, it's popped out again. Okay, well that's okay. I'm going to try and push that down a bit. It really is not happy about staying down. Oh, there we go. I've jammed it underneath, which is quite nice. So I also noticed that I've got some border sizes as well. So at the moment, I think the screen is quite small because I've brought in the bottom and the side borders. So if because they are again floating high. Now it's these bits here. So this is I think it's border X and border Y, and then I think this is border X and border Y here, and I think this is the high display enable, and then this is the low display enable, and the high display enable I think disables the entire clock output for the horizontal scan. So if I do this, poof, the whole screen kind of like stops, and if I enable it again, then the whole screen should, in theory, come back again. Yes. I think probably there's a little overflow timer or something like that, or maybe the video signal, the video signal detection hardware has detected that there's no sync, so that really does turn off the whole display. So then what happens is that I have to go back and let it, I remove it. It's just that this takes a little while to come up on the screen, probably because the screen itself has a bit of lag. So what I can do now is I can drive low the border, and if I drive low the vertical border input, then you can see that the screen gets bigger. Boink. Oops, I've just disabled the screen again. There we go. The perils of fiddling around with pins, right? So this is the horizontal border, and I've driven it low, and the whole screen has got wider, which is great, as expected. If I do the same with the vertical screen size, then the vertical screen size here gets bigger and smaller, bigger and smaller, and then the horizontal one. You can even see that the bottom right hand 8 pixels, right down in the bottom right hand corner, has this little notch when the full borders are enabled, or when the full borders are widened. And that's actually what I see in the simulation as well, and that's what I see in the software simulation based on the logic of this display as well. So that's a good sign. It means that the original display here has a little bug in the bottom right hand corner, but I don't think you ever see that on the bomb jack hardware, because I think that might be, it's rotated, don't forget the screen, so I think it might be the top right hand of the screen, maybe, which is the score panel, the bottom left or something like that. I'm not going to worry too much about that because I've never really wanted to fix that bug. So what this means now is that I've got borders which respond to the signal. I've got expected behavior when I've got the bus contention for the memory access. And lastly, if I tweak the pixel color, which is coming in on layer 1 here, okay, the pixel color here will, because it's layer 1, it has the highest priority. So if what I can do is that I can start tweaking different values here, and I should get different lookups from, if this floats it high, if I go back low again, then that shows me that it is picking different colored pixels, right? Depending on the palette lookup, but also depending on the value of the pixel. So this is 3-bit color with an additional 5 bits for the palette index, okay, because I expanded it from the original 4 bits palette index plus 3-bit color from the original Game Boy bomb jack hardware, sorry. I basically enabled all of the spare bit, which wasn't being used, but now it is. So we've got more colors than the original bomb jack hardware because it uses the full memory range of the palette RAM. So what I can do is that I can assert different palettes coming in by letting it float high or force low, which results in this kind of display as well, which is absolutely fantastic. So it kind of indicates to me that it's working really quite well. What I'm going to try and do is that I'm going to try and hook up the counter output into the pixel input, and we'll see if we get an expected different display of varying pixels on the rendered display. So I'm going to try that temporarily, one moment, and I'll see what that produces. So what I've done here is that I've taken the lowest bit from the 1 megahertz 74161 clock or counter and tied that to the lowest bit of the input pixel. So as expected, we are now seeing alternation, and it's scrolling up because the 1 megahertz clock is obviously not in sync with the 12 and a bit megahertz clock for the display, and the internal 60 hertz timing of the display means that the 1 megahertz clock is out of sync. So that generates a nice slow pulsed scrolling effect, basically asserting different pixels on the input header here. So we're seeing 2 colors scroll around a bit on the screen. So this kind of shows now that the board, the video generation board, is working as expected. So I feel confident now in going ahead and starting to build something or to buy something which will give me much more control over the memory interface here, the data input, because what I've done here is that I've tied a simple static value coming in on the data bus lines, and also the memory address. I want to buy something now or make something, which will give me a lot more control. So then I can fully test this by programming a whole range of palette entries, and then checking to make sure that the layer combination logic here is working correctly. When I assert the correct pixel value, then I expect to see the information reflected from the palette entries. So I'm going to do that now. What I can also do is that I've got the confidence now that I can actually build something which works. So that means then I can go and start constructing the character generation layer for the board, which I think I will do after I just debug a little bit more with a more extensive debugging memory interface, the exact expected behavior of this board. And some of these temporary connections, like for the variable resistors here, I'm going to be making a little bit more permanent, I think, by either finding some variable resistors that I can solder in place, because these are kind of like the ones which are long and thin, where you have a screw thread. Well, there's got a screw thread here, but you can either tweak it manually or you can tweak it with a screwdriver to adjust the resistance. I might try and find some in my bits box from one of my previous projects, or I might just solder it up. We'll see how that goes. But all in all, good progress on proving that this works. And of course, it's not able to focus on the screen that well because the pattern is confusing the autofocus on the phone, which is quite funny to see. Things to note is that, again, these memory chips are quite hot, but what is really boiling at the moment is this poor thing here. It's actually too hot for me to touch. So this poor little, I think it's a 7805, is really being worked very hard. I might have to, before I start adding an extra character layer board to this, I'm going to have to really think about having a properly managed power source for this, because this is really getting too hot to touch, which makes the rest of this too hot to touch as well. Whereas in normal operation, this is not too hot to touch, and this is not too hot to touch either. So I'm really taxing it quite hard. So I'm going to really have to think about a 5-volt proper regulated supply for this. But all in all, it works, and I'm really happy that it works. It's taken a very long time to actually even get to this stage of poring over schematics and making sure that the analog and electronics will work and stuff like that. So good progress so far. Progress with the build. This is the character screen generation board. I'll just turn off the light. There we go, that's probably a bit better. So it's taken 1 hour and 27 minutes to solder up almost every single IC socket on the board. This side is all taped up. One moment, I'll get rid of the tape. And as if by magic, the tape has disappeared. So most of the sockets are now properly populated. It's just these large RAM sockets left to go here, and then the same kind of header arrangement on this side of the board, and also the little bank selector, and then the pixel output header here. And then, like the other board, so if I bring the other board in, there's actually some progress on that one too. So after the initial debugging session, the remainder of the header sockets here have been added, including the expansion memory bus and the row column internal video header. This is actually a video header too. This one contains all of the clock signals, the MDL, VPL, CDL, etc. This little jumper header here is now smaller. These ones have been, these variable resistors aren't really variable resistors anymore, they're just zero, hopefully zero resistance wires, just soldered in on the other side. So I've already done a visual inspection just to make sure that, before taping it obviously, that all of the sockets are the correct way around when I plop them in, which they are. Check 3 times, solder once. It's always a good rule. I turn it around a little bit that way. So it only took 1 hour 27 minutes to do all of this soldering, and I had a 5-minute hand break in between because my hand holding the soldering iron was beginning to cramp a little bit. So, you know, not too bad actually. Quite painless. The soldering iron performed really well. The solder was really nice, as it was on the video board. I've done a visual inspection with magnifying glass of all of these solders, and they all seem to be good. I've double checked all of the pins that are incredibly close to wires, like these ones here. These ones are, you know, you just have to be a bit careful with ones like this, especially like these. Put the soldering iron on the side of the hole furthest away from the wire, and feed the solder in furthest away from the wire. And if you feed it in slowly, the solder with its flux will just wick around and then down through the hole, and then that's it, then you stop. So all in all, a good job this evening. It's quite late, I'm quite tired, so I'm going to leave it there, and tomorrow I'll just add the rest of the sockets and the headers, and then we should be good to go. So my plan for tomorrow, once all this is headed up, is obviously populate the sockets with ICs. But before I connect the 2 boards together with this lovely large long range of longer pins, what I'm going to do is that I'm just going to make sure that this board still works. Hopefully it will. Hopefully I've not destroyed anything when I've been soldering all of this. So I'm just going to connect it back again to that breadboard and the video conversion, and just see if it all works. It should do. Should have no problem at all. I also got a nice bunch of extra wires today. These are very pretty, but they're going to do the job a lot better and a lot more stably than the other wires that I've got. So these are going to have really nice, sensible connections. I won't need to wiggle around wires into little holes and stuff like that. Everything should be nice and perfect now. Much neater. Okay, time to go to sleep now. See you all tomorrow. One small bit of progress with the video generation board. I've added these connectors up here, and although I'm unable to get any sync just by using the RGB connections here, when I use one of the TV syncs or color syncs from here and pipe that into one of the sync on greens on this input here, using, I think it was AV1, it was able to sync. So that's useful to know. But one of the other useful things to know is that when I connect up the header here using this little VGA pass-through breadboard here, and then I pass it into this. What I can do is that I can get a well-synced signal using H-sync and V-sync. Now, H-sync this is the H-sync, the yellow wire. H-sync can come from the color sync here up at the top right hand corner of the header, or I can move the H-sync down to the bottom right. Now the bottom right is just the H-sync component here. So if I unplug this and I plug it into the bottom right hand corner, which is in here, then the video decoder board is currently detecting a 264 RGB HV signal at 59.66 Hertz. What's interesting to note is that if I move the H-sync signal from the bottom right and move it back to the top right, which is TV sync out, then the video conversion box still detects a 264p signal with RGB HV, and I still see that on the screen, of course. But the interesting thing to note now is that if I go back here and I change the input signal now to be the second one, which is RGB and separate sync, it now detects 261p at 60.31 Hertz, which gives me that kind of display. So that's interesting that now the video decoding box is able to detect and decode both types of signal. I would prefer to use separate RGB HV, really, because that's horizontal and vertical sync as two separate signals. That's what all of these connectors are meant to kind of supply: separate RGB, and then H and V sync, and then the TV sync, and then the TV sync out signals as well, just for completeness. So this video decoding box not only takes VGA in, but this VGA is obviously RGB and separate HV, but it can also be a combined signal for sync. But it also takes separate RG and B here, and I think it was sync on green and sync on blue. The sync on green and sync on blue currently doesn't work with this board because I'm not outputting any kind of sync signal on green or blue. And the SCART, I did dig out a cable earlier on which looked like it was an RGB SCART cable with composite sync, and I tried that with these syncs here, but it didn't actually quite work. So I'm not entirely sure why. I mean, I've not found a SCART RGB HV cable yet, but that's basically what this is right now, just coming in through the VGA connector. That's what my large multi-format Sony TV was detecting as well. I think, when I connected up the Commodore 65 via this same hacked together VGA cable output. I think the TV was just basically detecting it as a kind of like a 50 hertz, or maybe 60 hertz, because the Commodore 65s that I've got are prototype ones. I think maybe they're NTSC rather than PAL. I'm not entirely sure, actually. I'd have to check that. But either way, the machines are outputting just basically separate H and V sync with RGB. And the TV was detecting that and just rendering it as if it was either a VGA signal with that particular timing or a SCART based signal, because I was able to feed it through the VGA connector, but I was also able to feed the same signals into a SCART cable and plug in the SCART cable into the back of the old TV. A little bit like what this box does. So what I've also been doing today is that I have been experimenting properly with more accurate and reliable connections to the pixel input header here, but also more reliable connections using these new nice color-coded wires here, and feeding in better memory signals here to the memory bus, and also here too for the expansion memory bus. Basically validating that, say for example, if I output a pixel here which alternates between 0 and 1, or alternates between 1 and 2, then just validating that I can change one or both colors that appear on the screen here by using the memory interface. And I've been able to successfully check that I'm able to set individual bytes in the palette RAM here, say for example by making a grey color, or by making a light pink color, or green, or whatever, just to make sure that the values that I'm setting into the memory here are being correctly reflected here, and I'm actually able to validate that I'm getting good analog color, as far as I can tell from tweaking values on the internal memory bus. So after all that, I'm just going to continue making the character board, which is currently sitting over here. I've got a few more when I've got the memory headers, memory bus interface to connect up, and then I've got the wider sockets to solder in as well, and then I'm going to start populating the thing and connecting it together. So relatively good progress today in the short amount of time that I've had. It's interesting to note with regards to the HV or sync signal variations coming into the video box. I guess it's just depending on how this thing displays the rate, but nevertheless, interesting to note.